We've all experienced the effect of focusing on a subject that is close to the camera with a wide open aperture and seeing how there is very little depth of field. In this lesson, we are going to explore how this works and how best to deal with it. The easiest way to see this is to plug in some different values into our depth of field calculator and see what results we get. So we're checking out the depth of field calculator again to see what happens when we change the distance of our subject. So right now, we have this set up for a crop sensor camera, specifically the Canon crop sensor cameras, which uses a circle of confusion of 0.02 millimeters and a 50 millimeter lens at f2.8. Right now, we'd be focusing on our subject about 10 feet away. And with these settings, we get a depth of field of around 1.35 feet or 16 inches if you prefer. Now let's see what happens if we change this distance of 10 feet to something like 3 feet, 36 inches. Now we're looking at a depth of field of around 0.12 or a little less than 1.5 inches. That's at 3 feet away from your camera. You're getting about 1 inch of depth of field at this distance. If we decrease that again, say to 2 feet away, we're looking at a half of an inch of depth of field. I mean, that is super shallow. Some 50 millimeter lenses will be able to focus even closer. The 17 to 50 zoom lens that I like to use a lot can focus at just under a foot. So if we put in 12 here, you're looking at 0.14 of an inch. That's super tiny. So you can see how when we change the distance to our subject, the depth of field changes drastically. From 1 foot to 3 feet, we get from 0.14 to 1.39 inches. If we just go to 72 inches, which is 6 feet, we double that again. Now we're about 5 3/4 inches for depth of field. If we go to 12 feet, 144, now we get almost 2 feet, just shy of 23.5 inches. Changing the distance to the subject without changing the aperture or the focal length drastically changes your depth of field. But why exactly does this happen? Let's take a look. We know that at this distance in our simulated scene, we have approximately 7 units of depth of field. It doesn't matter what they are, it's just an example. This is because the points at the close and far end of the depth of field are inside our maximum circle of confusion. The subject in our case is this ruler. As we move the subject closer to the camera and keep the focus point on the same spot on our subject, our depth of field gets smaller. The points at the 1 and the 7 marks on our ruler don't change and are the same distance relative to the point of focus. Because we have moved them closer, their focus point relative to the sensor has changed. This causes their blur spots to be bigger than our maximum circle of confusion and thus not acceptably sharp. So how does this make any difference when you're shooting in the real world? Well, let's imagine for a moment that you are shooting some candids in a dark interior. You have a 50 millimeter lens and you want a cool looking out of focus background. So you crank that aperture open to f1.8. You're going for some close shots, about 3 feet away. You want to stop motion blur, so you're going to use a shutter speed of 200 or 2/50th of a second. You want to hit the focus on the eyes. Now think about this. Unless you stop your subjects and freeze them from moving, you're going to have very little chance of getting the eyes in focus, or really anything in focus. This is because you are dealing with a depth of field of less than an inch. The slightest movement, breathing, head tilt, etc. will place your depth of field in an undesirable location. It's really hard. And this is also assuming that your lens is able to focus on the point where you want it to, which doesn't always happen. Your best bet to help you get a little bit more in focus might be to take a few steps back, or stop down your lens to f4. Maybe use a wider lens, or use a flash to bounce a bit of extra light. Now that you know that your subject distance can drastically affect your depth of field, you're ready to check out the next lesson: depth of field and focal length.